Systems of nonlinear equations. Graph each equation of the system, then solve the system. So let's take a look at A here. It says negative 2x squared plus y equals negative 5. So what we're going to do first is actually solve this for y. So y is going to equal 2x squared minus 5. And then what we're going to do here is just think about what's going on with the graph of this. So this is saying, hey, I'm shifting down 5 and doing a vertical stretch of 2. So we're going to take into account those two things. And one more thing here, let's find the X-Intercepts. So to find the X-Intercepts, that means my y equals 0. And then that tells me 2x squared minus 5 equals 0, because there's my y there. And then when I solve, I'm going to get x equals plus or minus the square root of 5 over 2, which is about 1.58. And I'd just like to get an idea of what that is before I do my graph here. So right away I know that it's going to shift down 5 in a vertical stretch of 2. And then a point I like to think of is when I plug in a 1 here, what do I get? That means I'm going to the right one. What value is that going to give me? So that's going to be negative 3. So I put that one in. And because of symmetry, I have one on the other side of the y-axis. And I just try to pick values I know. So essentially I'm doing an xy table here. So then when I go where x is 2 at, that's going to give me a positive 3 in there. So at 2, it's going to go 1, 2, 3, which is there. And let me just draw a better dot there. And then on the other side, there's the same place across the y-axis. 1, 2, 3. It's going to be there. Now I can actually draw a, oops, wrong one. I went too far over. Should be 2 over. So there it is. So I can actually draw a nice graph now, and I know that my x-intercept is about 1.58. So there's our graph. Now we're going to graph the second equation. So again, I'm going to solve for y. So I'm going to move the y this way and the 9 this way. So I'm going to get y equals 6x minus 9. So then I would go 9 down, so 3, 6, 9. And again, this one's going to be a line, so that's my y-intercept. And then I'm going to go up 6, and then to the right 1. So I'll just put a few more dots on there. Now I just have to connect the dots. So there's our graph, and we can see that we intersect here and here. And that's what it means to solve the system. But we're going to solve this system algebraically here. And in most cases, when dealing with nonlinear systems, we usually use substitution method in order to find where these two equations intersect. So what I'm going to do is, since I have it solved for y, both of them, I'm just going to take this one, wherever I see y in the top one there, I'm just going to plug in 6x minus 9. So that's going to give me 6x minus 9 equals 2x squared minus 5. Okay, so now I'm just going to move everything over to the right side here because I want to keep my x squared positive. And anytime I see an x squared or higher exponent for my variable there, I'm always thinking standard form, just moving everything over the same side, 0 on the other side, and then factoring or quadratic formula if possible. So this is going to give me 2x squared minus 6x. And then remember, I'm going to be adding a 9 here because I'm moving it to the other side. So that means I'm going to get a plus 4, and that equals 0, because that means this would be 0 then, because I moved everything over. Okay, so now what we're going to do from here is try to factor if possible. I can pull a 2 out. I see that right away. So that's going to be minus 3x plus, plus 2, and that equals 0. So now can I factor this here? And I actually can. This actually factors nice. So this is going to be a 2. This is going to be an x, not plus, but minus 2, because that's a minus there. And then x minus 1. The signs have to be the same since I have a plus there. And then 2 times 1 is 2. And that equals 0. So then I get x equals 2. Now again, what I'll say first is I won't skip this step here. So this means x minus 2 equals 0, or x minus 1 equals 0. I'm not going to say 2 equals 0. That doesn't make any sense. If I was worried about the 2, I could just take the whole thing and divide both sides by 2, and then that 2 is gone anyways. And then 0 over 2 is 0. But I don't have to do that. I just realize it's a constant, and it's not going to result in anything as far as a solution, because it's a constant. Okay, so anyways, I'm going to add the 2. So x equals 2, oops, or x equals 1. So those are my two answers for x. So since I'm solving a system, I actually have to find the y values as well, because it's an ordered pair. Because when I think about two equations intersecting, they intersect at an object called a point. So that has both an x and a y intercept. Now I'm going to plug it into the one that's easier to compute. And that's going to be the bottom one here. This one here is going to be a lot easier to compute the y value. So when I plug in a 2 where I see this x at here, that's going to be 2 times 6, which is 12, minus 9, which is 3. So this is going to be 2, 3. And then when I plug in a 1 there now, that's 6 times 1, which is 6, minus 9, which is negative 3. So that's going to be 1, negative 3. And if I think about those 2 points on my graph here, 1, negative 3 is down here, and 2, 3 is actually up there. So that's where this system of equations intersects, and that's what it means to solve the system. So that's my answer for this one. So we graphed it, and that's the first part here. And then it says, then solve the system. And that's what we ended up with down here. So that's our answer for this problem.